Hey Dakota, it's Miss Tracy. So let me help you with this first problem. So we've got the base of a right prism whose height is 11 feet. So that means 11 is the dimension that goes here. And the base is this trapezoid. So that means this shape here. That's the base area, is that. We're going to find the surface area of the prism. Dimensions are in feet. So we have the width of each one of the sides given here. So this would be 3, this would be 8, this would be 9, and this would be 10, right? Each one of these sides, we have the dimensions for it. And then we have the height. We also have these two trapezoids. We want to find the area of the trapezoid and then multiply it times 2. So it's 2 times the area of the base plus each of the 4 sides. So each of the 4 sides, I guess. I'm just going to put each side. That's what you're doing to find the surface area of the prism. Now there's a couple of ways that you could do this. So we know how to find the area of the base. We break it into 2 shapes that we can actually do the calculation on. So we would have area 1's a rectangle and area 2 here is a triangle. So we'd find those values there and we would multiply and we'd add them back together for area 1 and area 2. Now you could do the lateral surface area 2 different ways. You could either A, find each shape. So for instance, you've got this shape here at the end. You've got like the skinny rectangle that goes down and it is 3 and then 11 tall, right? So that would be this side right here. Then you have this side right here, which would be a little bit bigger as a rectangle, and it would be 8 times 11, right? Then you have the bottom or this back side, or I guess for us it's the front side, and it's a little bit bigger because it is going to be 9 by 11, right? 9 by 11 tall. This is still 11, all the way around it's 11. And so then the final side is this slopey side, which is this bit right here. So we've already done the 9. So then this last part is going to be a rectangle that is 10 by 11. So we could do that, right? So then that one would be 10 by 11. So we could do the math for all of these. So 3 times 11, that'd be 33 feet square. 8 times 11 would be 88 feet square. 9 times 11 would be 99 feet square. And then 10 times 11 would be 110 feet square. So that's all of the sides. You just add all of the sides all the way around together. The other way to do that is to add all of these together and multiply it by 11. So it'd be 3 plus 8 would be 11, plus 9 would be 20, plus 10 would be 30. So you would have 30 times 11, which would be 330 feet square. And that is the area, that's the dark green area all the way around the sides of this prism. Now if we add these together individually, we should get the same number. So 33, 88, 99, 110, right? 3 plus 8 is 11, plus 9 is 20. Write the 2, 0, carry the 2. 5, 13, how am I doing that? 2 plus 3 is 5, plus 8 is 13, plus 9 is 13 plus 9 is 22, plus 1 is 23. So 3 carry the 2. 2 plus 1 is 3. So 330 feet squared because it's the same, right? Okay? I just had to stop. My brain is getting old. I've made too many videos this week. So it's the same amount whether you do it as individual sides or if you add all of the sides together and multiply it by 10 all at one time. Doesn't matter. So that's going to be every side added together. That's 330 feet squared for that amount. Now 2 times the area of the base would be 2 times, and we're going to find the area of area 1. That's 3 times 8. That's going to be 24 feet squared. Okay, so 24 feet squared plus you've got the area of this triangle, which we know is going to be base times height divided by 2 because it's a triangle. So 9 times 10 is 90 divided by 2 is 45. So 45 feet squared. Okay, so we're going to add those together, those two areas. It's going to be 2 times 69 feet squared. 2 times 69 is going to be 8. Carry the 1. It's going to be 12. It's going to be 138. Yeah, 138 feet squared plus so we can add these two together. I'm going to do them on top of each other because that's just easier for my brain to see. So it'd be 8, that'd be 6. So that would be 468 feet squared. Okay, so these are the two ways to do the sides. You can do each individual side, or you can get the perimeter of the base times the height, and that's lateral surface area. So lateral surface area is the area around the sides. That's what lateral means, is sides. So you could also call that side surface area. It would mean the same thing. The perimeter of the main shape times the height is the fastest way to do it, and that's the way we did it here. We added 3 plus 8 plus 9 plus 10 equals 30 times the height, which was 11, which gave us this. Right? It's the same thing as 3 times 11 plus 8 times 11 plus 9 times 11 plus 10 times 11, and then adding them all together. It's the same exact measurement. But so then you would put that in for the sides, the lateral surface area. So you've got the base area and the lateral surface area equals total surface area. And with the base, you have a top and a bottom. So you've got to say 2 times the area of the base to get the top part and the part that it's sitting on, the bottom. Okay, it's like wrapping paper. You got to go all the way around the box. And that's surface area. All right, I hope that helps. Just break the shape into 2 pieces. You could do it like a trapezoid and do 9 plus 3 times 8 divided by 2. But that's complicated. It's easier just to do this rectangle and this triangle and add it back together. This is the rectangle, this is the triangle. We added it back together. That's for one of them, so we multiplied it by 2 to get both of them, the top and the bottom, and then we just added the top and the bottom and the side area. This gave us the total. Okay? All right, I hope that explains that well. But that's all you're doing. You're just getting 2 of these and then each individual side and adding it all together. That's basically all you're doing. The way you do that is the way that makes sense to you. All right, let's look at the other one. All right, so this says to expand by using the distributive property, write the answer with exponents, posit, write each term in its own blank. All right, so let's do this. We're going to put this over 1 to make this a fraction, to make it easier to see. And I just write what is in the first fraction and then I write what's in the second fraction. And then I put the operation between the two. And then I repeat. I write what's in the first fraction. And what's in the next fraction. Then I write the operation. And I do it again. What's in the first fraction? The one that I'm distributing. And then what's in the fraction that we're on. So that'd be 4, d negative 2, b4. All right, so now I'm going to do a little bit of housekeeping. For this negative in front of the d, I'm going to put -1, just so I can keep track of the fact that there is a 1 there. There is a coefficient there, and it's a -1. That's going to help me do the math a little bit easier. So now I see I've got d negative 2, d positive 2. Those cancel each other out. I've also got a b4, b4. Those cancel each other out. So all I have in this first fraction is a -1 over +1. That's all that's left. So minus. Now I'm going to do this over here. I've got a d negative 2, d positive 2. Those cancel each other out. So the only thing I have in the numerator is another -1. And I've got a b positive 4, b negative 3. So I have a b in the bottom. That's all that's remaining. Now in that last fraction, I've got d negative 2, d negative 2. So that's going to be d negative 4. And I've got a -1 times a positive 4. So it's -4 d to the -4. And I've got b4, b4, so that's going to be b8. All right, so that's where we are now. Now I have to take into account, I need to get a common denominator so that I can add these together. So to do that, I am going to make all of my exponents positive. And all that means is I'm going to take this d4 and put it in the bottom to make it positive. Just like that. So now it's positive. So -1 over 1 is just -1, right? And now I have a negative times a negative, so that's going to be a positive 1 over b. Negative times a negative, that's going to be a positive 4 over b8 d4. And that should be your answer. You should be able to put a -1 here, 1 over b here, and 4 over b8 d4 here. I think that's right. Because it's looking for 3 terms, that would be the thing that makes the most sense to me. All right, so there's that for that problem. Let's look at the next one. All right, so here we need to simplify and write the answer as a simple fraction with all exponents positive. So this is a keep it, change it, flip it problem. So let's rewrite it. Z over, excuse me, I apologize for that. Z over x times, and we're going to flip this, x plus z over y. So we get z times x is zx, and z times z, this will be plus z squared, over x times y, which is x, y. That's all we can do. That is the problem right there. So remember to make this a 2, not a z. So I think you tried to cancel something in your answer here, but when you have an operation, you cannot cancel these x's. It has to be applied to the whole term. Now, if this had an x in it, you could take the x out of this and the x out of this, and that would be fine. But you don't have an x in both terms, so it doesn't apply to the whole thing. It has to be a factor, not an operation. So that would be how you would solve that. Just keep it, change the sign, flip the fraction, and then multiply. Z times x, z times z, x times y. Straight across. Here you go. Let's look at the next one. All right, so we've got add. Write the answer with all exponents positive. So in order to add, we need to find some type of common something, right? We need to get like terms. So in order to get like terms, we're going to need to get some denominator action going on. So we have negative exponents, so the easiest thing to do is to create fractions by moving these to the bottom. That'll be y squared, z to the negative 1 would just be z, plus x over 1, turn that into a fraction, minus 3y over z. Because this is z to the negative 1, we can move it to the bottom, and all's good. Now this is all written with all exponents positive, and now we can add. All we need to do is multiply this fraction by this denominator, and this fraction by y squared, because that's what's missing in these two. Because y squared z is going to be the common denominator. So that's what I'm going to do. I'm going to, let me move these apart just so I have plenty of room. We're going to multiply this one times y squared z over y squared z. And we're going to multiply this one times y squared over y squared. So that gives us w plus x y squared z minus 3y cubed over y squared z. And that would be your answer. Okay. All right, let's look at the, I think you have one more. Yes, here's your last one, I believe. It says, what is the linear equation of the following graph? So the linear equation is going to follow the format y is equal mx plus b. Now, m is the slope, that means the angle, and b is the y-axis intercept point. So we can find that by looking right here on the y-axis. It's -2. That's where the line crosses. The y-axis is at the -2. So we can immediately write that point right there. It takes the place of this b. B represents wherever it crosses the y-axis. So it crosses at -2. So that's what we're putting right there. Okay. Now we need to find the slope of the line. And the easy way to do that is just to count from one point to the next the direction and the squares that's going. So this is going down. Down means negative. So it's going to be -1, -2, -3. Okay. Then, so that's -3. And then we have 1, 2, 3, +3. So -3 over +3. This is the y is on top. So -3 is on top and +3 is on the bottom. So -3 over +3, -3 divided by +3 is equal to -1. So our slope is -1. So when we write a -1 in front of a variable, that's where we would put, that's what we would put in for m, right? Is -1x minus 2, because that's the slope of the line. But when we write a -1, we usually, the 1 is invisible. So what we would really write is y is equal to -x minus 2. And that would be the way you would do that. That's the process that you would follow. Okay? Now, if we had to go up to find this point, if it were up here, then this would be positive because up is positive. But when the line slopes down, it's going to be negative because down is negative, because down then is to the negative side of the y-axis. So that's the direction it's pointing. So that's why it's a negative sign. And the x is always to the right, so it's always positive because it's always toward the positive side of the x-axis. Also, because we have this rule about denominators, they always have to be positive. Denominators can't be negative. That's another reason. It falls right in line with that rule for fractions of having the denominator always positive. So we always count and make it positive because we go to the right. So anyway, That is, if you have any questions about how we found that, please ask. I think that's the last problem you had. Let me check. Yes, that looks like the last problem you had. If you have any questions or something you don't understand, please message me back and I will respond as soon as I have the opportunity. And I will see you next week. Stay warm, sweetheart. Bye for now.